Welcome to my projectbazaar.com. Yeah, let us discuss about the stochastic geometry study on device-to-device communication as a disaster relief solution. Yeah, let us discuss about the abstract of the product. So in this basic concept, device-to-device communication that enable direct communication between nearby mobiles is an exciting and innovative feature of next-generation cellular networks. So it will facilitate the interoperability and then interoperability between the critical public safety networks and commercial networks based on the for example LTE. So whatever it may be, the basic concept of D2D communication, in particular there are two types that is will be discussed about. Yeah, these are the types of D2D communication. So inbound and outbound. So inbound is separated into underlay, overlay, and then outbound is separated into control and autonomous. So these are the types of D2D communication of the system. And then the interference management schemes in D2D, that is interference avoidance. So to avoid the interference and the interference cancellation, in case the interferences appear, it should be cancelled the interfere, and the interference coordination. So interference coordination means it should be coordinate with the interference and it should be avoid and cancellation process. So the basic concept is D2D communication is must to calculate the value of the process. So these are the interference management scheme in the D2D communication. Yeah, and the next process, D2D communication that enable direct communication between the nearby mobiles, so that are easily calculating with the particular mobile. So nearby mobile device will improve the spectrum utilization, overall throughput and energy efficiency, while enabling a new peer-to-peer and localization based on the application and services. So in this proposed work, to analytically quantify the cellular network performance during massive infrastructure failure. So where some terminal can play role is an important role to multi-hop communication, namely the analytical determining for the D2D effect in alleviating damage caused by the disaster. So in this particular paper, a novel technology methodology, so wide scenario network condition and the parameters of the services. So this methodology amounted whatever it may be, it should be calculating the 3GB recommendation of the process. So finally the simulation is done by using the MATLAB process. Yeah, let us discuss about the flow diagram of the process. So these are the overall flow diagram. Here we using the network model. So and then deploy the cellular user randomly. So and then deploy D2D user, that is a D2D communication, and the communication link between the D2D user. And then overall allocator channels for a particular user. Here we are using the allocator channel, and then allocator channel here we are using the spectrum allocation. The spectrum allocation is there are two types. One is a RSA, that is a random spectrum access, and another one is a PSA, so that is a priority spectrum access. So finally performance analysis, calculating the transmission probability and SINR outage probability. So in the context of energy harvesting in wireless networks on way, to evaluate the performance of the system, under investigation is used to stochastical modeling. So gives the insight of long-term performance behavior and helps to select the statistically optimal network parameters. So these parameters are not necessarily optimal on the short time scale. On the other hand, tools from optimization theory can be used to model the network and evaluate the short-term performance to find the optimal parameters. So that should be maximize a certain objective of the functions of the process. So here we using the spectrum allocation for the RSA and PSA of the network. So that is in the uplink performance. So the RSA is need for the uplink of the particular value. So and then the PSA, that is also a downlink performance of the process. Finally calculating the whatever it may be. Then D2D communication is particular cellular user. The cellular user using the link of the process. So to allocate the channel, whatever it may be, user for the user bandwidth, throughput, efficiency, or all are calculated by using the value. So whatever it may be, we calculating the transmission probability, and then the SNI outage probability for the particular RSA and PSA algorithm of the process. So D2D deploy the user, communication link also is important of the process. So these are the overall flow diagram of the particular process. Yeah, now we let us discuss about the running procedure for the process. So click the main file, source file, and then run. So it's some time to display the values, and then we calculating for the deploy user, cellular user deployment, transmitter, receiver, and then communication link between the D2D communication user, like that. Yeah, and this next figure, the cellular user deployment. So these are the base stations. So base station are deployed in the pink color, and then cellular user are deployed in the plus mark. So all the cellular deployment and base station deployment in this figure. So in the next figure, that is calculating that. So D2D transmitter deployment. So in the transmitter deployment, D2D is functional in the red color, and then plus is a cellular user, and this is a pink generated by a base station of the process. So cellular user and D2D transmitter is like a base station of the process. So overall the particular value of the converted to the D2D transmitter and the value of the process. So in the next figure, D2D receiver deployment. So in the D2D receiver deployment, so here we're using the D2D transmitter and then receiver and then also a cellular user of the process. Next figure, the communication link of D2D links. The D2D links is between the base station, cellular user, D2D transmitter, receiver, and then communication link between the transmitter and receiver of the process. So this is the connectivity between the D2D receiver. So overall, which should be circle in the process of the particular communication D2D links of the process. So the next, in this figure, that is describe about the link level success probability. So in the link level success probability defined as the downlink and uplink, and then also a D2D and then total. So in the downlink process, this is a downlink process, and then uplink, it's denoted by the uplink, and then D2D is denoted by the D2D, and the pink is denoted by the total of the value. So this is a distance 0 to 1500. This distance is indicated by the meter, and then probability of the function. So that is 0 to 1. So this is the link level success probability of the particular value of the process. So in the another figure, the network success level probability against varying values of damage ratio, that is a D. So damage ratio indicated in D, downlink PSA, that is power spectral access, and then D2D, cellular K0, K1 relay and K2 relay. So in K1 relay, this is indicated in red color, and K2 relay is indicated in blue color. So cellular of K0 is indicating the process in the black color of the process. So more or less downlink and uplink is the important ratio of the process. So these are the damaging ratio and the network access probability of the particular system of the process. So these are the overall running procedure for the product. Thank you for listening this video.